Hi, this is Farhan from AlgosFromScratch, and I welcome you to this amazing YouTube playlist on building DistilBERT model from scratch using PyTorch. In this video, we are going to combine everything that we have been building, like the multi-head attention, feed-forward network, embedding layers. So I will just quickly start with the recap of our videos. So we started this playlist, like specifically this custom classes part. So we started with the embedding class, then we tested it with a naive classifier. We created then the single head attention. We extended it to multi-head attention. Then we created the feed forward network. We then created a complete transformer block where we also added the add and norm part, and then we stacked these transformer blocks 6 times in this DistilBERT model specifically. Now we are going to build our complete model all the way from embedding till the classifiers. So first part will have this embedding plus the overall encoder part. So in this overall encoder part, we will have our complete transformer block 6 times. So these 6 times stacked transformer blocks we are going to have right here. So embedding the output from the embedding layer will come to the stacked transformer block, first block, and then the same input that is coming to the first block will be repeating itself all the way from these 6 transformer blocks, and finally the output will be given to the classifier head. So here we will have the encoder, okay, these 6 times transformer blocks, and after this the output is going to be given to the classifier. Okay, so this whole part we have created already. This part also we tested it with the naive classifier, if you remember. So we are going to now combine this complete architecture, okay, all the individual blocks that we have been building, we are going to combine them now. Okay, so to start with this, I'll just switch to the coding screen. Okay, here you already are familiar with this notebook. Okay, so first of all, let me just see the model itself. Okay, this is the original model. So you can see we have this outer class. Okay, and I will just print the final, this stacked transformer block class. Okay, so this object, I'll just print it. Let me just print this, and let's see. Okay, so you can see now this transformer my till the output layer norm, it starts from this point and till this point. Okay, so this we already have. This embedding layer is already as an individual part, it is ready. So if I just copy this, copy cell output, I'll replace this. Okay, and I'll just clear this output. Now if I show you, this is the transformer block. Okay, and this transformer block, like this transformer class which contains these 6 transformer blocks, okay, we already have this right here. Okay, now if you just notice, this DistilBERT model class contains the embedding and the transformer part. Okay, so nothing complex, just keeping the embedding and this transformer, uh, stacked transformer class in this DistilBERT model class, nothing else. Okay, so we'll first start with this. I'll copy this. Okay, and I'll just come here and start with class this, and I'll just add my to this. Okay, so DistilBERT my, I will just inherit it with an module. Now, okay, so we have been doing this part. Okay, let me check if it is fine. I'll just accept the suggestions. Okay, because you already know this part. So first starting with constructor, then the super part, then embedding and transformer my. Okay, I'll accept these suggestions. One thing, I'm just going to check if this embeddings class, the spelling is basically correct. So if it is correct, then we will just execute it. Okay, naive classifier and this embeddings, yep, it's fine. So with this, now I'll just, okay, this is done. Now I'll just start with the forward. Okay, and this forward method is going to take first of all the, so it will be calling the embedding layer in this forward method. So definitely if we are going to call the embedding layer, so we will need input IDs. Okay, plus it also is going to use this transformer my class. Okay, and if you notice, this transformer my gets input IDs and attention mask. Okay, so these input IDs and attention mask, input IDs we are going to get from the embedding class. Okay, so this attention mask is the second argument we are going to have in this. Okay, now this input embeddings is going to be equal to self dot embeddings input IDs. Okay, so embeddings input ID, yep, right, and then this encoder output is going to be self dot transformer. Okay, yep. So I'll, if I take this get these suggestions, I will accept them. Okay, and yeah, so it is now then the input from the embedding class, we'll just pass it to the transformer block and along with the attention mask. Okay, so it is going to give us the output of the overall encoder part. Okay, like without the classifier. So I'll simply just execute it, and let me just copy this and I'll just paste it over here. Okay, let me paste it over here. Now I don't need to call this embeddings over here, so I'll just remove the embedding, and yeah, till this point. Now this transformer my object, I'll just call it the complete encoder object. Okay, and here I'll just call it the DistilBERT my. DistilBERT model my. Okay, so this is going to be the encoder output. Here I will just call this object, and here I'll pass the input IDs plus attention mask. Okay, and whatever the output is, I'm just printing its shape. Let's execute this and let's see if it works. Yep, it's working. Oh god, lucky me. So let's just now print the complete encoder object. I'll simply print it to show you. Okay, so now you can see this is now the combined form where we have the embeddings, then this transformer stacked class. Okay, so where we are stacking our transformer block till this point. Okay, so if you compare it with this, you can see this is the DistilBERT model class. Okay, it contains now this embedding and the transformer part. Okay, one thing now remaining, and that is this the final uh, outer box, that is the DistilBERT for sequence classification class. Okay, we are now going to wrap this class that we just created within this DistilBERT for sequence classification, and we will also add this classification head part in along with this encoder part. Okay, so we are now going to copy this and just let me paste it over here. Okay, I'll just add my to this. Okay, and now over here I'll just start with the okay, so constructor, all this I'll just accept these and explain it to you. Okay, so this is going to be the DistilBERT. Let me just see if the naming is similar. So this is the architecture of the original model. Okay, so it says DistilBERT, here is DistilBERT. Okay, it says the pre-classifier. Okay, all this pre-classifier, classifier, and dropout. Okay, so okay, now in this self I am going to need something. Okay, the first thing that I am going to need is the linear layer. It is basically this classifier 768 768 768 out features. So I will need dimension, I'll need the number of labels, and I'll need p of this classifier part. Okay, so let me just quickly copy the model config dictionary. I just copied the model config. Okay, and I'll paste it over here. Quickly execute it. Here I have this number of layers. Okay, and the dropout classifier. Okay, so this is the p part we are going to use in the classifier dropout. Okay, other than this we have number of labels. We already have these because we tested our embedding layer with the knife classifier, so we already have these. Okay, so we will use this and the dimension. Okay, so first let's just start with the dimension. Okay, so dimension is going to be equal to this model config dimension. Okay, and I'll just remove this from here. Here I'll just say dimension in, dimension out. Okay. And the next thing that I'm going to need is number of labels is going to be equal to the model config. Here I'll just say the number labels. Okay. Okay. And I think that is what else. Okay, so the number labels input, yeah, they drop out. Okay, so I will just also take the dropout p, and that is equal to model config, and I'll just simply take the classifier dropout. Okay, that is 0.2. Yeah, that is all. Now what else? So now we need this classifier and the dropout. Okay, so let me just copy this and paste it. Okay, so now the self dot classifier and then linear dimension labels out. Okay, done. And dropout is going to be dropout p. So yeah, these suggestions are right, so I'm gonna uh, accept these suggestions if I get them. Okay, so classifier is going to be equal to nn linear dimension number labels dropout this. Yep, fine. So with this, now our init method is done. Now we need the forward method. Okay, the forward method is now going to get the, first of all, it will call this DistilBERT model my. So DistilBERT model my takes input IDs and attention mask. Okay, so I'll simply pass the input IDs and attention mask. Okay, and after this, what we are going to do, we are going to pass the input IDs and attention mask to this DistilBERT model my object. Okay, it will give us the overall encoder parts output. Okay, and we will then pass the output to this classifier head. Okay, how we are going to pass it to the classifier head, that we are going to look now. Okay, and here I will just say the encoder output is going to be equal to self dot DistilBERT. Here I'll simply just pass the, to this DistilBERT I'll pass the input IDs plus I will pass the attention mask. Okay, when I will pass this to the in DistilBERT object, I'll get the output of the encoder part. Okay, then I have already done this part, this pooling and extracting the CLS token part, when we were discussing this knife classifier just after the embedding class. If you have not watched that video, I recommend you watch that video. You will understand all this specific part. I'm going to accept these suggestions. Okay, so it says pooled output encoder, all of the examples in the batch and from each example I am just going to take this CLS token. This CLS token I am going to extract all of its features, okay, like 768 features. Okay, so pulled out, then I am going to pass it to the pre-classifier. Okay, whatever I get from this pre-classifier, I'll just quickly check something else. Okay, let me just check the forward method of this final DistilBERT model for DistilBERT for sequence classification class in the original model. Okay, so I can do something like print model, and here I'll just print its type. Okay, and dot module. I'll just copy this. I'll say from this import the original class. Okay, I'll not be calling this my, I'll just be extracting this class. Yeah, so now I'll just import inspect. Okay, and get source. Yeah, done. So we've been doing all this in almost every video, so you must be familiar with this now. Okay, I'm going to get the source code of forward method of this class. Okay, I'll just simply execute it. Okay, so this is the forward method. Input IDs, attention mask. Okay, and then DistilBERT output. Okay, here is the important part. Okay, so it basically is applying this ReLU activation before passing it to the final classifier. So we will also apply this ReLU activation. Okay, just to have this similar kind of architecture, and then we will apply the dropout, and finally we will pass it to the final classifier to get our logits. Okay, so I'll just clear this selected output over here. After the pre-classifier, okay, so it is passing, this is correct. Okay, dot value, we are going to pass this pulled out, and finally here we will get our logits. Logits are going to be equal to self dot classifier. Okay, and we'll pass this pulled out from the dropout to this classifier, and this is our logits we just are getting at the end of this classifier head. Okay, so this is done. Let me just execute this. Now we will test it. Okay, so in order to test this, I'll simply just copy this. I'll paste it over here. Okay, so first of all, I'm getting the input IDs, attention mask, and this is now the my model. Let's call it my model. Okay, and here I'll call the same class, this one. Okay, and yeah, okay, and now I'll just say the model output or my model output. Okay, and here I'll call this my model, and in this my model I'm going to pass the input IDs and attention mask. Okay, so I'll just print this my model output dot shape. Let me just execute and check if we have. Okay, so we are getting the logits. Let me just uh, first of all show you the logits values, okay, and then I will explain this overall architecture, okay, one final time, so you have the big picture then again, okay, in your mind. So here I'll just say my model output, okay, and you can see we are getting these three values. So you remember we have three classes, okay, and these three classes are now getting their scores, like the logits values. We can convert them into probabilities using the softmax activation, but that we are going to do in the training loop, okay. So till now this seems fine. I'll just add another sentence over here. Let me say I want this meeting uh, again, okay, and exclamation mark, let's say. Now if I execute this, I should have 2 and 3, so it means two sentences, and for each sentence we have scores against all three classes, okay. I'll execute it and let's see if it works. Yep, it's fine. So if I just show it to you now, so you can see now uh, it now takes as many sentences as you pass, okay, to this model, and this model just executes all of these layers, modules, submodules, everything, okay, and finally it gives us this score. The score is nothing but three values, and these values are called logits. We simply then pass these logits to a softmax and we can get the probability distribution, okay, and that is the next part we will be doing. So quickly I am now just going to conclude everything, okay. So what this actually is doing, so if I show you this over here, you can see we have this output of tokenizer and we are taking the input IDs and attention mask, okay. So we are getting the input IDs and attention mask, okay. Input IDs, let's say if we have one sentence, so we will have input IDs of around like 1 to 128. Yeah. Our maximum size is 128, okay. So attention mask is going to be the 111 or 0 something like this, okay. So let's see if this is what we have. So I'll just come here and over here I'll just print the input IDs, okay, and before this I'll just make it one single sentence, okay. Yeah, done. This is our logit. So yeah, this you can see now it has the same shape just as I mentioned, okay, over here, this. So it will have 128 values, these input token IDs, 0 for padded tokens, and these are the real tokens, okay. And if I just print the attention mask, this is what we have in the attention mask, okay. Now when we call the model, what happens, these the input IDs, we pass it to the embedding layer, and embedding layer gives us the input embeddings. Okay, we take this attention mask, we pass this input IDs plus attention mask to our encoder part. And in this encoder part, we have then 6 transformer blocks. We pass this input embeddings uh, through all of these 6 transformer blocks. And at the end of this 6th transformer block, we get the output. Okay. And that output is nothing but the batch size, the sequence length, and the dimension. What we do, we take every sentence of the batch, we extract its 0th token, that is the CLS token. Always, if I show you here, you can see this input IDs always has this 101 token as a first token. So we are extracting that. Okay, and then we are having all of its dimensions. So dimensions are going to be 768. Okay, now we pass this 0th token from the pre-classifier, then the ReLU activation, then the dropout, and then the classifier. Okay, and that final classifier part has this input shape 768. So it will take all the 768 features and it will just give us 3 logits. Okay, and that is what we are getting in our output. So if let's say we have 3 sentences, then we will have 3 CLS tokens, and for each CLS token we will be having 3 logits. Okay, and that is exactly what we are getting over here. Okay, now I'll just quickly check the model architecture and we'll show you. Okay, so this is my model now, and if I show you this my model now, you can see this has the same structure like the original one. Okay, so we have this most outer class, then we have these 2 DistilBERT and transformer, DistilBERT, and the pre-classifier, classifier, and dropout. Okay, and then in this DistilBERT my class we have embedding and transformer, and in transformer we have then the 6 transformer blocks. Okay, and within each transformer block we have attention, like multi-head attention, SA layer norm, feed forward, and output layer norm. So this is all for today's video. I hope you enjoyed the video, and in the next video we are going to start our training loop. This same model from scratch, we will train it. So that is all. I see you in the next lecture. Till then, bye bye.